Problem 2 was those stacked up circular cylinders in the container. There's my number 2. And they were actually, let me see if I can actually draw a circle. Chances are the answer will be no. Okay. So let's see, if I hold shift down, then I get something circular, but that's not actually where I want it. So let me try again. Ooh, there's a circle. Okay. And now the problem, of course, will be to draw the same circle, which will be pretty much impossible. Yep. So, anyway, whatever. No, it's too big. See, now I can't do it. Something like that. And the third one, more or less directly below. No. Well, I'm trying too hard. Whatever. Nope, I'm just going to go back to drawing my crappy circles. Okay, so the important thing about these circles is the geometry that the problem has, where the container, that is actually, wow, okay, I didn't do too bad there. Wow, okay, boy, yeah, get a picture because this moment is not going to repeat itself. So the circles each have a center, the circles have a radius of little r, and then the container, I said, has a width of 3r. And what that means is, first of all, this distance here is r, okay, from this to this, because, actually, let me write r in down there, because the circle is going to be a distance r away from the wall, right? Okay, and or the center of the circle is going to be a distance r away. This one will also be a distance r away, and the edge of this guy should also be a distance r away from the side wall. Okay, not quite working because I'm not perfect at drawing, but this is still far better than I usually do, which means then if the total width is 3r, okay, so if this here is 3r, then this in the middle has to also be r. And what that means is that the distance between, or the horizontal separation between this point and this point is r, and the distance between these 2 points is 2r. That whole distance, and this whole distance is, of course, also 2r. So really what's going to happen is the centers of these circles are going to sort of form a 30, 60, 90 triangle. Well, kind of, okay? No, I mean, these will form like an isosceles triangle, but you get the idea, okay? So we're going to have a triangle between, say, the center of this guy and the center of this guy here is going to be a triangle that is, this is going to be a 30, and this is going to be a 60, okay? And this is, of course, going to be a right angle. So what this means is that the normal forces these cylinders exert on each other will be at 30-degree angles from vertical. So on this first cylinder, we just look at the first cylinder. Actually, let me draw, like, let me see if I can do this. Well, I wanted it black, didn't I? So I'm going to try drawing a black cylinder here. Okay, this is the top cylinder. And then I'm going to try drawing, okay, so the top cylinder is going to have, acting on it, it's going to have, first of all, its gravity, or its weight, is going to be mg going down. It's going to have a normal force from the wall acting on it, okay, and this is going to be Fn1. I didn't tell you what points to find the normal forces at, right? But what I meant was basically all the points where the walls touch the cylinder. So these 4 points here. So this is going to be the first normal force we have to find. This is going to be gravity down there. And then you're going to have a normal force coming from the other cylinder, from cylinder 2. So I'm going to call this, oh crap, now I've got a whole issue. So, I don't know, force normal, cylinder 1. Okay, I don't know, whatever. But you get the idea. There are 3 forces acting on this cylinder. There's a normal force here, and its weight. And there's no friction, of course, because we said there's no friction. This guy acts at a 30-degree angle from vertical, okay? So, and that's 30 degrees there. So now, if we want to do an FBD of the top cylinder, then what we're going to have is this. You're going to have mg acting down, you're going to have the normal force from the wall at point 1, okay? And then you're going to have this FNC1, which is a horrible name, but whatever, okay? So FNC1, and there's an incoming call that I probably don't care about. Uh-oh. Okay, hold on. Now, how the hell can I pause this thing? No, that's not going to do it. Am I paused? I think I'm paused. No, I'm not paused. Well, whatever. There's somebody calling the wrong number. Yeah, okay, because I don't recognize the number. So this angle here is 30 degrees, okay, and that's 30 degrees there. So I'm just going to do that. And what this means is that when we sum of forces equals MA, then when we do this, this horizontal component of FNC1 is going to be FNC1 times the sine of 30, which is 1/2 of FNC1, okay, FNC1, and this force is going to be √3/2 times FNC1. So this is the component breakdown of this guy, and then this is going to be FN1, whatever that is, and this is going to be mg. And sum of forces x is FN1 to the right minus 1/2 FNC1 to the left, and that's going to equal mass of the thing times AX, of course, which is 0. Sum of forces in the y direction, you've got √3/2 times FNC1, and then minus mg equals mass times AY. I'm really scribbling this in horribly small, so I apologize for that. But since AX and AY are 0, these guys are all in static equilibrium, they're sitting there, then you can solve then and say, let's see, √3/2, so this is taking the y equation, okay, √3/2 times FNC1 equals mg, and all that's saying is that what's holding it up against its own weight goes down, and then the √3/2 times this force goes up, and those two have to balance, okay? So that means then that this FNC1 is 2mg over square root of 3, and that's the normal force between these two cylinders. Okay, so not pretty, but it works. And then in the x direction, we have that that normal force. Sorry, Fn1 to the left. Wait a minute. Oh, to the right. Sorry. Equals 1/2 Fnc1, and so that first normal force is going to be half of this, so it's just going to be mg over square root of 3. So at point 1, the total normal force from the wall is going to be mg over square root of 3. Wow, stop it. All right. That's not what I wanted either. Okay. Why am I getting a circle now? I don't want a circle. I want to, there we go, over square root of 3. That's better. Okay, so that's the normal force there at this point. And now, I mean, I guess you have to keep going through here, right? So we know what this FNC1 is. Now on 2, you're going to have, well, we'll see how far I feel like doing this. But on the middle one, FBD for the middle cylinder, okay? So now the middle cylinder is this one, okay? Of course, it's got its weight, okay, mg. It's got that Fn2, so that's the force here. It's got that, then it's got Fnc1 going to the right and down because that's this. Sorry, these are all vectors. Okay, mg. And then it's got what I'm going to call FNC2 going up and to the left. And these both make a 30-degree angle with vertical because FNC2 is the force from this cylinder, FNC1 is the force from this cylinder. You've got N2 pushing to the left from this point, and then you've got the weight going down. Well, so let's see. How far do we want to go with this? Sum of forces, MA, and that FNC1 we already know. So let's see. That's going to be... I don't know. I'm starting to get tired of this. Actually, we know that FNC1, or the vertical component of FNC1, is going to be equal to mg going down. I don't know. What's going to happen here, I think, let's see, is that you're going to have mg. This force is going to have to be double the magnitude of this force. I'm pretty sure, because it's just my intuition. Trying to solve this. So if you look at, I'm going to sort of skip ahead in my head and say that I can tell you if you do a free body diagram of all three of these guys together, okay, so imagine now taking all three of them together and doing an FBD. Well, they have a total mass of 3m, right? Which means the total weight of them will be 3m downward. And the only upward force on them is going to be this normal force here. I'm sorry, the weight will be 3mg going downward. The only upward force will be this normal force at this point. So the magnitude of this force will have to be 3mg. And then you could actually go backwards from here, and knowing this force has to go this way, to find what this force is, also with gravity there. Let's see, I don't know. Let's see, it's going to be 2mg downwards, which means 2mg over root 3 that way. So I bet you almost anything. Yeah, I remember solving this now. This one from the left is going to be 2mg over root 3, and this one from the right is going to be, really it'll be 3mg over root 3, which is also equal to just square root of 3 times mg on this side. So, there you go. I sort of skippity-skipped through this stuff, but you can do it all with some free body diagrams. You need to do 3 of them total. You can, if you want, do like the first free body diagram being just all 3 of them together, and then find this guy, and then maybe do a free body diagram of just the little one, or just the bottom one to find this, and then this one I just did. That's probably the most efficient way. So do the free body diagram of the whole thing to find this vertical force here, okay? And then step 2 would be to do a free body diagram of this guy, and the fact that you know which direction this normal force points lets you figure out what this has to be, given that you also have the weight of this guy. And then maybe you can do an FBD of the top one like I did and figure that out. And then once you've got this force and this force, then you can go back to your first free body diagram, which was all 3 of them. And since the forces horizontally have to balance, you know this plus this has to equal that. Okay. It's a little exercise in geometry, and whether you can keep your angle straight as you go around. It's pretty symmetric. I would say almost, if I had to redo it, I would just make it 2 of these, because I feel like having 3 just makes it too difficult. But of course, I will forget that, and then next year I'll give next year's students the same 3-cylinder problem, and remember after I show them how to solve it that this is too complicated and I should have done 2. And the cycle of pain will continue. Anyway, that's enough on problem 2.